Welcome to Millennials with Mics, discussions about movies, politics, religion, and more. I'm Aaron Mason.
And I'm Christian Stevens.
Today we'll be talking about a question that a lot of people think they know about, and a lot of people know they don't know a lot about, which is evolution. Specifically, what is evolution? So there's the dictionary definition, which is a change in populations of organisms that through time lead to the occurrence of new form. Your thoughts?
Well, like you said, that is the definition of evolution. And so if you don't like that, I mean...
It's kind of a cop-out answer, though.
It's a very generic answer.
When people ask what is evolution, that's not really what they mean, right?
Well, it seems like a lot of those definitions are trying to be a little ambiguous, so you're not really... It's technically a definition, but it's also like not stepping on other people's toes, I guess, in a way.
Yeah,
it's like a moderate definition.
And when people say what is evolution, they're not really looking for a definition. What they really normally mean is how does evolution work, right?
Right, and they want more key answers as to like how everything came to be what it is today.
Yeah.
How are we here? Where do we come from? Monkeys or what have yous, and all that together. How are animals here? Birds and bugs and all that.
So, we aren't biologists.
No.
We aren't any type of scientists whatsoever.
So don't hold us to Big Bang Theory standards.
But I have a heavy interest in a lot of different scientific areas. A layman's interest, or an extended layman's interest, I guess. But no, we aren't biologists. We aren't scientists. So don't just take our word for it, no matter what. And that could be said of anything. Science, religion, anything we talk about on here. Don't just take our word for it. If you have questions, do some research.
Yeah.
But, to be able to give a 10,000 foot overview of something based on research and what fairly good resources say that we can do to maybe answer in a way that most people could understand, I guess.
Right.
Because even
kind of simplify what people think.
Anything you research about it is going to be very confusing.
Yeah.
And
depending on who you ask or who's looking for these answers, and if people just want a more technical thought, who you have a deep read into how evolution works, or if you just want like a kind of a simple but more like definitive answer than what Webster Dictionary gives.
Yeah,
precisely. But yeah, some people like you read about it, it makes your brain hurt, and some people are like just so enthralled by reading about it that it's like very informing for others and not make your brain hurt. So
but so we'll go over a few common questions and common rebuttals to evolution, I guess. The first one being, like we said, when most people say ask what is evolution, they really mean how does it work?
Right.
So there's 5 key areas with evolution that it's not one of them that drives everything. They all work in tandem. They're all necessary.
Multiple little things that come to play to make what it is today.
So the first one that we're going to go over being genetic drift, which occurs with smaller populations. And this isn't just of humans. This is of any life form.
Species, really.
Yeah. So genetic drift, think of it like this. You have 5 red bugs and 5 blue bugs.
Right.
Through death, be it by disease, be it through predators, something like that, say 4 of the blue bugs die. You have 1 blue bug left, and you have all 5 of your red bugs left.
Mm-hmm.
In a given amount of time, when mating and reproduction has had a chance to occur, you're eventually going to see that 5-to-5 ratio turn into initially a 5-to-1 ratio.
Right.
And then a 10-to-2 ratio in favor of the red. because the one blue bug left was able to mate with one or multiple of the red bugs.
Which then become, like you said, a mutation of that, which would be like purple bugs, for example.
Theoretically, yeah. But there are so many more red bugs. There's 5 times as many red bugs as there was the one blue bug.
So, yeah.
You're still going to have way more of the red bug than you would of the blue bug after it's all said and done. Because that one blue bug, and even its descendants, that one blue bug is only going to be able to make so much.
Right.
And then there's going to be less and less blue bugs until potentially all the blue bugs die out.
Or extinct.
Or go extinct. And there's only the red ones left.
And
maybe some traces of the blue bugs in the DNA of the future red bugs because it did reproduce somewhat.
Right.
That's an overview of genetic drift. It occurs in smaller populations. And due to various other circumstances can lead to the one type versus the other gaining a majority. The next form of evolution, or the next key to evolution, I guess, is non-random mating.
Non-random.
And, I mean, that's a confusing term in and of itself, right?
I mean, it's not... Yeah, like, what do you mean by non-random?
Well, theoretically, no mating is random for one reason or another.
Right.
But when scientists say non-random mating, they really mean that individuals in many species have a choice about which partners to mate with.
Right.
The result of which is that some people have more opportunity, or some things have more opportunity to mate and reproduce than others. Let's not to pick on any one person in particular, one type of person in particular, but let's say redheads. Redheaded humans.
Right.
Regardless
less redheaded humans than there are brunettes and blondes and...
Yes, and let's say that, whether some people want to claim this is true or not, that's, again, not a biologist. I'm not going to say it's true now. But let's use that as an easy example. Let's say people found redheads unattractive, which is crazy, but let's say they did.
Well, with
eventually,
all groups, there are attractive and unattractive people.
But just in general, no.
Can't just say all redheads are unattractive.
Exactly. But let's say that was the view.
Right.
So people stop mating with redheads. Eventually, redheads are going to die out altogether.
Precisely.
You might have a gene mutation here and there that occurs that a random redhead will pop up. But eventually, theoretically, there would be, if people stop mating with redheads, there would be no more redheads.
Right. That gene pool will just go.
That is a preference that is an example of non-random mating. Non-random mating is really about preference through one way or another. Whether it is a physical preference or a biological preference, you have no control over, something like that.
Right.
Another example, there's assortive non-random mating, which is a preference for similarity, be it looks, genotypes, phenotypes, something like that. And then there's disassortive mating, which is the preference for different looks, genotypes, phenotypes, etc., etc. Non-random mating, it really is about preference rather than whoever's closest to you, or whoever's available, I guess.
Right.
Then you have gene flow. This is simply migration. You have one group of people, or like you have a group of birds. You have a group of white birds, and a red bird comes and
mates with a white bird.
Starts mating with white birds.
Right.
That is new DNA that's brought into the white bird.
Starts a new thread of bird species.
They start mating. The red birds and the white birds' eggs, their hatchlings look different. They mate with each other. Eventually, they mate and mate and mate. Eventually, you have a whole new species of bird that's not red or white birds.
Precisely.
They could be pink or purple.
So you went from like 2 to now there's a third to the third. Then it's going to be like a 5, and then that boom, 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 and it gets bigger and bigger and bigger.
A common example of that, I think, is Darwin's finches.
Oh, okay.
I think that's non-random, or that's a gene flow. I could be wrong, but I think it is. You had finches that got blown onto an island near South America.
And then started mating with
They started mating with what was there, and then eventually these two different types of the same species of bird formed into, there's now like 14 species of finches on the island, something like that.
So now you got a whole new
14 whole new species.
Exactly.
Of the bird. That's crazy. Then you have natural selection. This is something that everyone thinks they know what it is, and I promise you don't, most likely. So natural selection is, some people refer to it as survival of the fittest. It is kind of that, but it's nature favoring reproduction.
It's the opposite of your like non-random mating.
Kind of, yeah. It's
to an extent, right?
Mating not by preference, mating by what's
available.
What's available due to the circumstances.
Precisely.
A good example that we have here is mice. Say you start out with 3 mice that are similar to the color of the ground, and 6 mice that are not the color of the ground. They're lighter, they stand out.
Mm-hmm.
Some of those mice might have a genetic susceptibility to a form of mice cancer.
Yeah.
So let's say 2 of the mice die.
Mm-hmm.
Well, the rest of the 4 mice, they stand out from the ground. So 2 of them get eaten by birds.
Mm-hmm.
You have 2 light mice left.
You don't have much to pick from.
And you still have your 3 dark mice.
Right.
Well, your 3 dark mice are going to mate with each other and produce a lot more dark mice. Your 2 light mice can still mate with each other, but there's going to be so many more dark mice that by the time you get done with it, there's going to be few to no light-colored mice left.
Mm-hmm.
That's natural selection. Through genetics and predators and things like that,
right?
It's favoring what's reproducing. It's completely natural. Is essentially random. I mean, it is random. Mm-hmm. It's adaptation to your environment. There's another example of giraffes. Giraffes with long legs and short necks are going to die because they can't reach the trees. Or giraffes with long necks and medium legs are going to live because they can reach the trees.
Yeah.
The giraffes with genes that make them shorter and not able to reach branches, they're going to die because they can't live long enough to mate. Mm-hmm. The ones that can reach the branches to eat are going to live long enough to mate, and their genes are going to live on, and eventually you're going to have
more
mostly just giraffes
right.
that are long enough, they're tall enough and all that to reach branches to mate long term. So that's going to change the way the giraffes look, the way they, you can reach new things of eating. That's going to get in there. It's going to change everything for that species. And then you have the thing that really drives all of it, which we've mentioned a couple times, is genetic mutations.
Mm-hmm.
Without that, evolution really wouldn't be possible.
Because what would evolve if they didn't have the genetic mutations?
Yeah.
Because that's pretty much what that means.
Yeah. You have the mutants in X-Men, things like that. That's not real. That's not what we're talking about, right?
Well, right. Yeah, so genetic mutation, don't go thinking, gotta watch all these X-Men movies now, because that's not the...
Yeah, and
that's not what
if you think, if my baby's born with a mutation, it's going to have Wolverine claws, they're going to be able to walk through walls. No. That's not what mutations are. Everyone on Earth...
fact, not science fiction.
Yes, everyone on Earth is a mutant. Everyone has some form of genetic mutation.
Of course.
It's extremely common. And genetic mutations, it's what's at the heart of evolution. Mm-hmm. Because natural selection wiped out type A.
Yeah.
Eventually, slowly, but eventually wiped out type A. That means that type B and C had a chance to mate within themselves, mate with each other, and then
make whole new strains of
keep producing type A or type B and type C, and even producing type B or type D, which in humans' case became prevalent and then the only type. And that leads us to human evolution.
Even though this is a presidential election, there are many more candidates on the ballot besides the president. Go to Ballot Ready for a nonpartisan guide to your entire ballot. From there, you can compare candidates based on stances on issues, biography, or endorsements, and then save your choices to use when you vote by mail or in the voting booth. You can even request your absentee ballot or make a plan to vote early or on election day. This election matters. Make sure you have a plan to vote and vote informed. Local elected officials affect our lives every day. They decide who to prosecute, monitor the quality of our drinking water, and choose leadership of our own schools. Go to ballotready.org and enter your address to make a plan to vote and vote informed.
We'll lead with the questions, how did humans evolve? And did they evolve from monkeys?
Right.
Did they evolve from monkeys? The simple answer,
no.
No. Just no.
And a lot of people think because a lot of people do think, oh, we evolved from monkeys, and they automatically think it's modern day monkeys that you see today. Mm-hmm. And then it's that terrible, that diagram of the monkey
the ascent of
to
man.
the ascent of man and monkey to caveman to what we are today. And that's just simply not true.
It's not. I mean, there is, at the time that was published, they thought that was accurate. And it's still a decent example of
it's somewhat
what came first to what came later, but overall, that is not accurate. But how did humans evolve? So humans are primates.
Right.
That's just, we are part of the primate family.
Right.
We did evolve from creatures. Everything evolved from single cell organisms.
Right.
But later down the road, that single cell organism led to the evolution of the primate, which we would consider today, just based on looks alone, we would say looked like a monkey.
Mm-hmm.
Might not really look like any monkey that's alive today, but it looked like some type of monkey. So in that sense, I can see where that question would come from just by looks.
Right.
But we aren't descended from any modern day monkey.
And maybe because people know that we're part of the primate family, as expansive as it is, that's enough for people to just simply be like, oh, humans, primates, monkeys, primates, boom, we're from them.
And that is a very simplified view, and it is just not true.
Right.
We are related to modern day monkeys. We are not descended from them.
Right.
We all have a common ancestor, us with chimps, because chimpanzees are our closest
That's right.
relatives. But chimps, gorillas, orangutans, any kind of monkey you can imagine, we have a common ancestor.
I mean, a lot of people don't know this, though, but Donald Trump's a direct descendant of an orangutan.
You got to be careful. He sued Bill Maher for saying that.
Yeah, well, I think Bill Maher was onto something. That's just for fun. I'm not seriously saying
that's not true.
That's not true.
But yeah, so we do have a common ancestor with all monkeys. At what the common ancestor was, the most recent common ancestor will vary from species to species. Our last common ancestor with chimpanzees was closer than it was to gorillas, or than it was to gorillas, or whatever the case is.
Right.
But with every single monkey on the planet today, we have a common ancestor. We are all related. We did not descend from any monkey you can see alive today.
Precisely. It's just like humans, monkeys and birds and everything else also evolved. So
yes,
we weren't what we looked like hundreds and hundreds of years ago. Same goes for every other animal and species on the planet. So people need to keep that in mind.
But how did humans evolve? So you have a primate species,
and
like we said, over
genetic
hundreds and
flow
thousands,
and
millions
mutation
of years,
all that together.
Genes changed.
Right.
To adapt to the environment, things like that.
And how the world was.
And that led to the creation over millions and millions of years of new types of primates.
Mm-hmm.
Then you get to Australopithecus, which that was a prehistoric ancestor of humans, which led to actual humans, Homo erectus, Neanderthals, Denisovans. There's lots and lots of types of humans. Homo sapiens, and that's another key thing. Homo sapiens are not just humans, or humans are not just Homo sapiens. Humans are any species within the Homo genus.
Right.
Neanderthals, any of those that are named, Homo erectus, whether they look like us or not, they're all humans. Human is not just Homo sapien.
And for those who might be confused, just in case, Homo sapien, by definition, is human beings. A
modern human.
Not homosexual. So that's a different thing altogether. So just don't get those confused, my friends, because I know a lot of people make jokes about that. You say that
in jest, but it is funny how many people
right.
don't realize. They hear Homo sapien, they're like, whoa, what are you talking about?
All the time.
It's sad, but I mean that is something that is still there.
That is still there, exactly.
But no, you had several different types of Australopithecus. I mean, we're looking here: Australopithecus, Gari, Afarensis, Africanus, things like that.
A lot of issus.
But then that gave birth. Those evolved into the Homo genus. You had Homo rudolfensis, Homo habilis, ergaster, naledi, erectus, heidelbergensis, Neanderthals, and then Homo sapiens. There was a lot more than that. There were more of the Homo genus than just that we're talking about. But, and how did humans evolve? We evolved from all of those things, but they still don't really know for certain which are those that humans evolved from.
Yeah, these are just like the different
things
that we could have. Yeah,
we didn't evolve from like we lived when we first came on the ground in Africa. We did evolve from something like one of these things, but it wasn't Neanderthals. We lived around the same time as Neanderthals. Right. We actually mated with Neanderthals.
What's a good thing to bring up, because a lot of people do think that as well.
Yeah, and like that's not the case. But scientists don't know for sure.
Right.
The closest guess they have right now is that modern humans, Homo sapiens, evolved from Homo heidelberg and heidelbergensis, however you say that. That is their best guess right now. They don't know that for certain.
Gotcha.
What they do know is that when Homo sapiens came around, you still had Neanderthals and Homo erectus even for a little while. I think Denisovans, which were a subspecies, I think, of Neanderthals or Homo erectus one, I think they were still around too, but since they're a subspecies, they don't count.
Gotcha.
But we evolved from some of these things due to changes in the environment, which put natural selection to work and let things evolve to modern humans that we have today.
Yeah.
Like I said, we met, it used to be thought that we wiped out all the Neanderthals. And even maybe Homo erectus.
Okay.
Because they knew that we lived at the same time. Like that, they knew that fairly recently.
But they're not here today. So.
They knew that Neanderthals weren't around today. And the general thought was, oh, well, they must have met and Homo sapiens must have just wiped them out. Because that's what worked it out. That's not actually what happened.
Okay.
That could have, that's not to say that there were no fights necessarily between Neanderthals and modern humans.
Right.
But by and large, that's not what happened.
Right. Maybe due to genetic mutation and gene flow.
Yeah.
They died out just quicker.
Yeah, Neanderthals weren't the stupid cavemen that they were long thought to be.
Right.
Scientists are fairly certain that the Neanderthals could speak.
Oh, okay.
Or at least form some sort of primitive language. They used tools.
Mm-hmm.
They were social, not as social as humans were, but they were social. They lived in smaller groups as to where humans lived in bigger groups. But they did meet humans, modern humans, Homo sapiens.
Interesting.
And they mated. We know that because of DNA. Except for native Africans, Europeans and Asians and their descendants thereof all have 1 to 3% of their DNA is from Neanderthals.
Interesting.
And originally it wasn't even thought that was possible because they're two different species.
Right.
They're both of the Homo genus, but they're two different species, and it wasn't thought that
they could mate.
Two different species could reproduce.
Okay.
You can mate, like you can have sex all day long, but it wasn't thought that they could successfully reproduce. With primates in particular, that's not the case. I watched a documentary that says with any species of primate, 2 different species can successfully reproduce, so long as their most recent ancestor was within the last 2 million years.
Oh, that makes sense.
So, for Homo sapiens and Neanderthals, that meant, and even Homo erectus possibly, probably not, we haven't seen any evidence for that, but it's still possible.
Right.
That could have happened. We know it happened with Homo sapiens and Neanderthals. That could not happen with Homo sapiens, modern day humans, and any other monkey on the planet.
Right.
That was more than 2 million years ago. It's impossible. But for those in that specific case, Neanderthals and Homo sapiens, they did reproduce. Because Neanderthals weren't as social, like they were social creatures like us, they weren't as social. They didn't necessarily communicate with other groups of Neanderthals as much as Homo sapiens did, which meant that they couldn't share in technology as much, and that they were really, Neanderthals might have met a total of 100 other Neanderthals in their lifetime. Right. As to where Homo sapiens could have met thousands. Yeah. That the quote-unquote technology, just as simple as like arrowheads, ways of storing water, things like that.
The wheel.
They didn't meet as many other Neanderthals because they weren't as social, and it just didn't make them capable enough to survive long term.
Makes sense.
Then you add in mating with Homo sapiens, they just eventually died out. Mm-hmm. As did all the Homo erectus and all of the others. They eventually died out. Homo sapiens were the most resourceful. They were the most social. They were able to survive to what we are today, for better or for worse. Right. So, that's a very long chicken and the egg answer for that. Yes. But that is an overview of how humans evolved. Does that all make sense? Does any of it not make sense? Does it bring any questions?
Are you asking me? Mm-hmm. Oh, no.
No,
that's very straightforward.
Very straightforward.
In my opinion.
So, let's do the question, because this is an evolutionary question. Okay. Which came first, the chicken or the egg?
If you really had to, pick, obviously it would have to be the egg, wouldn't it? Because the egg hatches and makes the chicken, then you get the chicken.
But what laid the egg?
Evolution.
So, evolution, it's not quite as simple as what came first, the chicken or the egg. Mm-hmm. But if you're going to be so literal about the question...
think about it this way, too. The chicken or the egg. Well, the dinosaur egg came before a chicken now, didn't it?
And we know birds are types of dinosaurs.
Yes.
So the chicken or the egg, the evolutionary answer is the egg.
Right.
Yes, something had to have laid the egg.
Have you seen Aliens? Oh my god. That's another joke, but
But the egg had to be first because what came out of the egg was a modern chicken. Yeah. From this, like a very simplified answer to this question, the egg hatchling was a modern chicken. What laid the egg was a quote-unquote proto-chicken. Interesting. Not a modern chicken like we would consider today. But through evolution and gene flow and things like that, the egg came first that hatched the modern chicken.
Right.
Yes, something was there before it to lay the chicken, to lay the egg that hatched the chicken, but the egg came first for the modern chicken.
Even if it's not like the egg we think it is today, maybe like a single cell egg that did it to then make more eggs and then chickens and eggs and then chickens, and that's how it comes about.
So how about you ask us or make our 2 statements?
Is this on? Okay. So evolution is just a theory, so it can never be proven, huh? Well, no. Incorrect.
So why is it incorrect? It's that theory.
Right.
Because that's what trips people up.
Right, exactly.
When people say theory, most people, when modern people, anybody
it's
who would
say
this question,
well, it's just a theory. So,
and that's not a scientific theory.
Right.
A scientific theory is well tested, has a broad explanation,
has a lot of evidence behind it,
but is also open to change.
As science is.
A big part of what a theory is.
When new information comes about, then we learn
you have to change the theory with it.
Exactly.
No theory is exhaustive.
Right.
But to give it a comparison, like, okay, evolution is just theory, it can't be proven. Well, guess what? So is gravity.
Yeah.
Evolution is the same type of theory that gravity is.
Right.
So if you don't believe that evolution is a theory and can't be proven, then you don't believe in gravity. Oh, well, gravity has laws, and we know that gravity is there because of how it affects things.
Well, we got to be cautious of today's ideal look on how things are, because we got people today who think the Earth is flat. So it's just a matter of what people want to take as fact and want to pretend like it's, you know what I mean?
Yeah, it's ridiculous.
It's got people's yearning for what's true is just wild.
But
these days,
if you want to say that gravity or that evolution isn't possible because or isn't provable because it's a theory, that means you have to reject gravity too.
Mm-hmm.
It really does. I'm sorry to be like that, but that's how it is.
Well, that is how it is.
Gravity, yes, there are laws of gravity. There have to be laws of gravity because we know that gravity affects how gravity affects things.
Right.
But we know that for evolution too. Is the thing. People just aren't as accepting of that. Sadly. But it's the exact same type thing. So yes, in science, when you say a theory, you're not saying, oh, well, I'm theorizing that X, Y, and Z is coming through the door right now.
Mm-hmm.
It's not that kind of theory. You could make a theory about someone coming through the door, scientifically, but it's not just saying, oh, my theory is X, Y, Z.
Yeah.
It's not a theory behind a murder.
Right.
And then what's our next statement?
An all-powerful creator still could have set evolution in motion. So that's an interesting one.
We're not going to get into this question super duper much.
We'll just kind of give a broad little...
We're going to suffice it to say that there are several different religions out there, as well as several Christian denominations, that accept evolution as compatible to their beliefs. There are many, many who don't, but there are also many who do.
Right.
Whether that is what you believe or not is up to you.
Precisely.
So we are not going to go into that on this episode. We might on a future episode.
Yeah, so stay tuned.
So that is right now our high-level view of what is evolution.
Yeah.
We went into some uber basic stuff, but I think we went into some areas that a lot of people don't realize and that might help some people understand. Like we said, we are not biologists. Please, please, please
But you don't have to be one to give,
correct,
a grand example of like how things are about today.
Yeah.
So you don't have to be like super smart about it and stuff. But
hope
this helped kind of give people a sense of evolution of what it is and how it is. So.
I do want to encourage everyone to do their own research. I want to give some unsponsored plugs to some areas. Amazon Prime Video has a couple of good series and specials from PBS to watch. I think it's them that has The Evolution of Us.
Okay.
But if you go on Amazon Prime, do an Evolution of Us, Human Evolution, there are a couple of really good specials that'll pop up. They're from The Evolution of Us. I think it was its own thing. They have another one from PBS from Nova that was like a 3-part thing. They're hour and a half long. Very, very good resources. It gives a lot of good information that's not stupid level, but it's not like ridiculously high level. Like
meets in the middle.
Not for people with PhDs.
Sure.
We'll say that. People hear PBS, it's got to be so smart. It's simple enough to where anyone can understand if they're paying attention.
Mm-hmm.
That would be a good one. Not everyone has Amazon Prime. I get that.
So for them, tough. Just kidding.
The Khan Academy, actually. KHAN.
Interesting. Is that on?
It's free. It's online.
Oh.
Sal Khan is the guy who started it. They do videos. They're totally free. You can sign up. You can donate to support them. And I would highly encourage that. But they do simple videos going over a lot of topics. For kids in school, for college kids, exam preps, things like that. But they have a really good one over evolution in general.
That's cool.
And that is more, it's to where middle school, it's designed to where middle school and high school kids can understand it.
Yeah. So
it's going to be fairly straightforward, easy enough to understand. If you don't have something like Amazon Prime or access to PBS On Demand or something like that, that would be my next recommendation. So, anything else on evolution before we end this episode?
Nothing I can say that won't be said in a future.
Controversial?
Yes.
Okay. Well, that's it for Millennials with Mike. We'll see you next time.
Bye.